Sodium chloride, also known as salt, common salt, table salt or halite, is an ionic compound with the formula NaCl, representing equal proportions of sodium and chlorine. Sodium chloride is the salt most responsible for the salinity of the ocean and of the extracellular fluid of many multicellular organisms. In the form of edible or table salt, it is commonly used as a condiment and food preservative. Large quantities of sodium chloride are used in many industrial processes, and it is a major source of sodium and chlorine compounds used as feedstocks for further chemical syntheses. A second major consumer of sodium chloride is deicing of roadways in sub-freezing weather. Chemistry: solid sodium chloride. In solid sodium chloride, each ion is surrounded by 6 ions of the opposite charge as expected on electrostatic grounds. The surrounding ions are located at the vertices of a regular octahedron. In the language of close packing, the larger chloride ions are arranged in a cubic array, whereas the smaller sodium ions fill all the cubic gaps between them. This same basic structure is found in many other compounds and is commonly known as the halite or rock salt crystal structure. It can be represented as a face-centered cubic lattice with a 2-atom basis or as 2 interpenetrating face-centered cubic lattices. The first atom is located at each lattice point, and the second atom is located halfway between lattice points along the FCC unit cell edge. Thermal conductivity of NaCl as a function of temperature has a maximum of 2.03 with K at 8 K and decreases to 0.069 at 314 K. It also decreases with doping. Aqueous solutions: the attraction between the Na+ and Cl ions in the solid is so strong that only highly polar solvents like water dissolve NaCl well. When dissolved in water, the sodium chloride framework disintegrates as the Na+ and Cl ions become surrounded by the polar water molecules. These solutions consist of metal aqua complex with the formula Na, H2O, 8+, with the Na-O distance of 250 pm. The chloride ions are also strongly solvated, each being surrounded by an average of 6 molecules of water. Solutions of sodium chloride have very different properties from pure water. The freezing point is at 21.12 AA degrees Celsius for 23.31 Wt% of salt, and the boiling point of saturated salt solution is near 108.7 AA degrees Celsius. From cold solutions, salt crystallizes as the dihydrate NaCl 2 hours 2O. Unexpected stable stoichiometric variance: common salt has a well-established 1:1 molar ratio of sodium and chlorine. In 2013, compounds of sodium and chloride of different stoichiometries have been discovered by a team at Stony Brook University. 5 new compounds were predicted. The existence of some of them has been tested and experimentally confirmed: cubic and orthorhombic NaCl3 and 2-dimensional metallic tetragonal Na3Cl. This indicates that compounds violating chemical intuition are possible, in simple systems under non-ambient conditions. Occurrence: small particles of sea salt are the dominant cloud condensation nuclei well out at sea, which allow the formation of clouds in otherwise non-polluted air. Production: salt is currently mass-produced by evaporation of seawater or brine from brine wells and salt lakes. Mining of rock salt is also a major source. China is the world's main supplier of salt. In 2010, world production was estimated at 270 million tons, the top 5 producers being China, United States, Germany, India and Canada. Salt is also a byproduct of potassium mining. Uses: in addition to the familiar domestic uses of salt, more dominant applications of the approximately 250 megatons year production include chemicals and deicing. Chemicals production: salt is the source, directly or indirectly, for the production of many chemicals, which consume most of the world's production. Chloralkali industry: it is the starting point for the chloralkali process, which provides the world with chlorine and sodium hydroxide according to the chemical equation, 2NaCl plus 2 hours 2OCl2 plus H2 plus 2 NaO. This electrolysis is conducted in either a mercury cell, a diaphragm cell, or a membrane cell. Each of those use a different method to separate the chlorine from the sodium hydroxide. Other technologies are under development due to the high energy consumption of the electrolysis, whereby small improvements in the efficiency can have large economic paybacks. Some applications of chlorine include PVC, disinfectants, and solvents. Sodium hydroxide enables industries that produce paper, soap, and aluminium. Soda ash industry, via the Solvay process, sodium chloride is used to produce sodium carbonate and calcium chloride. Sodium carbonate is used to produce glass, sodium bicarbonate, and dyes as well as a myriad of other chemicals. In the Mannheim process and in the Hargreaves process, it is used for the production of sodium sulfate and hydrochloric acid. Standard: sodium chloride is an international standard that is created by ASTM International. The standard is named ASTM E534-13 and it is the standard test methods for chemical analysis of sodium chloride. These methods listed provide procedures for analyzing sodium chloride to determine if it is suitable for its intended use and application. Miscellaneous industrial uses: sodium chloride is heavily used, so even miscellaneous applications can consume massive quantities. In oil and gas exploration, salt is an important component of drilling fluids in well drilling. It is used to flocculate and increase the density of the drilling fluid to overcome high down-well gas pressures. Whenever a drill hits a salt formation, salt is added to the drilling fluid to saturate the solution and to minimize the dissolution within the salt stratum. Salt is also used to increase the curing of concrete and cemented casings. In textiles and dyeing, salt is used as a brine rinse to separate organic contaminants, to promote OE salting out of dyestuff precipitates, and to blend with concentrated dyes to standardize them. One of its main roles is to provide the positive ion charge to promote the absorption of negatively charged ions of dyes. It also is used in processing aluminium, beryllium, copper, steel and vanadium. In the pulp and paper industry, salt is used to bleach wood pulp. It also is used to make sodium chlorate, which is added along with sulfuric acid and water to manufacture chlorine dioxide, an excellent oxygen-based bleaching chemical. The chlorine dioxide process, which originated in Germany after World War I, is becoming more popular because of environmental pressures to reduce or eliminate chlorinated bleaching compounds. In tanning and leather treatment, salt is added to animal hides to inhibit microbial activity on the underside of the hides and to attract moisture back into the hides. In rubber manufacture, salt is used to make bunner, neoprene and white rubber types. Salt brine and sulfuric acid are used to coagulate an emulsified latex made from chlorinated butadiene. Salt also is added to secure the soil and to provide firmness to the foundation on which highways are built. The salt acts to minimize the effects of shifting caused in the subsurface by changes in humidity and traffic load. Water softening: hard water contains calcium and magnesium ions that interfere with action of soap and contribute to the buildup of a scale or film of alkaline mineral deposits in household and industrial equipment and pipes. Commercial and residential water softening units use ion exchange resins to remove the offending ions that cause the hardness. These resins are generated and regenerated using sodium chloride. Road salt. The second major application of salt is for deicing and anti-icing of roads, both in grit bins and spread by winter service vehicles. In anticipation of snowfall, roads are optimally anti-iced with brine, which prevents bonding between the snow ice and the road surface. This procedure obviates the heavy use of salt after the snowfall. For deicing, mixtures of brine and salt are used, sometimes with additional agents such as calcium and magnesium chloride. The use of salt or brine becomes ineffective below a 10 degrees Celsius. Salt for deicing in the United Kingdom predominantly comes from a single mine in Winsford in Cheshire. Prior to distribution it is mixed with less than 100 ppm of sodium hexacyanoferrate, 2, as an anti-caking agent, which enables rock salt to flow freely out of the gritting vehicles despite being stockpiled prior to use. In recent years this additive has also been used in table salt. Other additives had been used in road salt to reduce the total costs. For example, in the U.S., a byproduct carbohydrate solution from sugar beet processing was mixed with rock salt and adhered to road surfaces about 40% better than loose rock salt alone. Because it stayed on the road longer, the treatment did not have to be repeated several times, saving time and money. In the technical terms of physical chemistry, the minimum freezing point of a water-salt mixture is at 21.12 AA degrees Celsius for 23.31 Wt% of salt. Freezing near this concentration is however so slow that the eutectic point of a 22.4 AA degrees Celsius can be reached with about 25 Wt% of salt. Environmental effects: road salt ends up in freshwater bodies and could harm aquatic plants and animals by disrupting their osmoregulation ability. The omnipresence of salt poses a problem in any coastal coating application, as trapped salts cause great problems in adhesion. Naval authorities and shipbuilders monitor the salt concentrations on surfaces during construction. Maximum salt concentrations on surfaces are dependent on the authority and application. The IMO regulation is mostly used and set salt levels to a maximum of 50 mg per meter. Two soluble salts measured as sodium chloride. These measurements are done by means of a Brill test. In highway deicing, salt has been associated with corrosion of bridge decks, motor vehicles, reinforcement bar and wire, and unprotected steel structures used in road construction. Surface runoff, vehicle spraying, and wind-blown actions also affect soil, roadside vegetation, and local surface water and groundwater supplies. Although evidence of environmental loading of salt has been found during peak usage, the spring rains and thaws usually dilute the concentrations of sodium in the area where salt was applied. Food industry, medicine and agriculture. Many microorganisms cannot live in an overly salty environment. Water is drawn out of their cells by osmosis. For this reason salt is used to preserve some foods, such as smoked bacon, fish, or cabbage. It can also be used to detach leeches that have attached themselves to feed. It is also used to disinfect wounds. Salt is added to food either by the food producer or by the consumer, as a flavor enhancer, preservative, binder, fermentation control additive, texture control agent and color developer. The salt consumption in the food industry is subdivided, in descending order of consumption, into other food processing, meat packers, canning, baking, dairy and grain mill products. Salt is added to promote color development in bacon, ham and other processed meat products. As a preservative, salt inhibits the growth of bacteria. Salt acts as a binder in sausages to form a binding gel made up of meat, fat, and moisture. Salt also acts as a flavor enhancer and as a tenderizer. In many dairy industries, salt is added to cheese as a color, fermentation, and texture control agent. The dairy subsector includes companies that manufacture creamery butter, condensed and evaporated milk, frozen desserts, ice cream, natural and processed cheese, and specialty dairy products. In canning, salt is primarily added as a flavor enhancer and preservative. It also is used as a carrier for other ingredients, dehydrating agent, enzyme inhibitor and tenderizer. In baking, salt is added to control the rate of fermentation in bread dough. It also is used to strengthen the gluten and as a flavor enhancer, such as a topping on baked goods. The food processing category also contains grain mill products. These products consist of milling flour and rice and manufacturing cereal, breakfast food and blended or prepared flour. Salt is also used as seasoning agent, for example in potato chips, pretzels, cat and dog food. Sodium chloride is used in veterinary medicine as emesis-causing agent. It is given as warm saturated solution. Emesis can also be caused by pharyngeal placement of small amount of plain salt or salt crystals. Firefighting. Sodium chloride is the principal extinguishing agent in fire extinguishers used on combustible metal fires such as magnesium, potassium, sodium, and NaCl alloys. Thermoplastic powder is added to the mixture, along with waterproofing and anti-caking materials to form the extinguishing agent. When it is applied to the fire, the salt acts like a heat sink, dissipating heat from the fire, and also forms an oxygen-excluding crust to smother the fire. The plastic additive melts and helps the crust maintain its integrity until the burning metal cools below its ignition temperature. This type of extinguisher was invented in the late 1940s in the cartridge-operated type shown here, although stored pressure versions are now popular. Common sizes are 30 pounds portable and 350 pounds wheeled. Cleanser. Since at least medieval times, people have used salt as a cleansing agent rubbed on household surfaces. It is also used in many brands of shampoo, toothpaste and popularly to de-ice driveways and patches of ice. Optical usage. Defect-free NaCl crystals have an optical transmittance of about 90% between 200 nm and 20 AA micrometer. They were therefore used in optical components operating in the infrared spectral range, where few non-absorbing alternatives exist and where requirements for absence of microscopic inhomogeneities are less strict than in the visible range. While inexpensive, NaCl crystals are soft and hygroscopic. When exposed to the ambient air they gradually cover with frost. This limits application of NaCl to dry environments or for short-term uses such as prototyping. Nowadays materials like zinc selenide, which are stronger mechanically and are less sensitive to moisture, are used instead of NaCl for the IR spectral range. Biological functions. The long-held belief that a high-salt diet raises the risk of cardiovascular disease is coming under scrutiny. More recently, dietary salt was demonstrated to attenuate nitric oxide production. Nitric oxide contributes to vessel homeostasis by inhibiting vascular smooth muscle contraction and growth, platelet aggregation, and leukocyte adhesion to the endothelium. See also. References. This article incorporates public domain material from the United States Geological Survey document, a SALT A. External links. The Salt Manufacturers Association website, Salt United States Geological Survey statistics and information, using salt and sand for winter road maintenance. Road Management Journal. December 1997. Calculators, surface tensions, and densities, molarities and molalities of aqueous NaCl, vapor pressure of NaCl solution, J. T. Baker MSDS.